Hi everyone, here's your first exam set, not exam, first homework set from your chapter 18. So this is quite straightforward and easy stuff, but let's see how we can approach these problems. Okay, the first one, pretty easy. The substance H2SO3 is considered. H2SO3 is sulfurous acid. So you need to figure out whether it is a neutral compound, weak Arrhenius acid, strong Arrhenius base, Arrhenius acid, strong Arrhenius acid, or a weak Arrhenius base. Remember, we learned about three ways that we can define acid and bases. One is Arrhenius acids and bases, which is if you have hydrogen in the acid or base, that considered as an acid, and if you have a OH group, that considered as a base. That's the Arrhenius acid base definition. And for the Lowry and Bronsted-Lowry definition, acid is something that can donate a hydrogen, base is something that can accept a hydrogen. That's the Bronsted-Lowry. And then the Lewis acid base is, Lewis acid is something that can accept a lone pair of electrons. Lewis base is something that can donate a lone pair of electrons. So for the Lewis acid base, it doesn't talk about protons. It's just a lone pair, acceptance or a donation. So H2SO3. So let's look at our slides for our chapter 18. Here we can see strong acids. What are the strong acids? So there are 6 strong acids, and they are right here in this slide. The hydrohalic acids, hydrochloric, hydrobromic, hydroiodic, these are strong acids, and also oxoacids in which the number of oxygen atoms exceeds the number of ionizable protons by 2 or more. For example, nitric acid, sulfuric acid, perchloric acid. HNO3, H2SO4, HClO4. So here there's one hydrogen and there are oxygens 3. 2 hydrogens, number of oxygens are either double the number of hydrogen atoms or more. So 2 times 2 is 4. So there are 4 here. And then 1 and 4. So these 6 are very common strong acids that we used in our day-to-day life. And if you come across any other acid, you can check to see if the number of oxygen atom exceeds the number of ionizable protons by 2 or more. That would be considered as a strong acid as well. For example, something that you don't have here but we can consider as a strong acid is H2Se, selenium. So this is sulfur, this is selenium O4. If you have this acid, what do you think about this one? Is it can we consider this as a strong acid? Yes, because the number of oxygen atom exceeds the number of hydrogens, number of ionizable protons by 2 or more. Right? So this is also a strong acid. And then the weak acid. So anything that you don't have, like these 6, other than these 6 strong acids, anything else you can consider as weak acids. Okay, hydrohalic acid, HF, is a weak acid. And then acids which hydrogen not bonded to oxygen, hydrogen cyanide. And then oxoacid in which the number of oxygen atoms equals or exceeds the number of ionizable protons by 1, like hypochlorous acid, nitrous acid. And then carboxylic acids, when you have this group COOH, carboxylic acid, and they look like this when you expand their structure. Carboxylic acids, they are also weak acids. Okay, and then all right, so with that in mind, we can go back here, close, go back here. The substance H2SO3, what do you think that is? Is it a neutral compound, acid, base? It is an acid. Correct, H2SO3 is an acid. What is it? Is it strong? There are 2 hydrogens and 3 oxygens. Has the number of oxygen atoms exceeded the number of hydrogen by 2 or more, 2 times or more? No, right? So that is then a weak Arrhenius acid. And it is not one of those 6 strong acids that we had seen, right? And then the substance HOBr is considered. Again, that is an acid, right? So the base is considered as OH, but here it's not a hydroxide. Hydrogen is at the front. So this is a hypobromous acid, which you guys learned in your Chem 1. Remember, we learned about hypobromous acid, bromous acid, bromic acid, perbromic acid, depending on the number of oxygen atoms. So this is an acid, and that is a weak acid. Remember, it's not one of those strong acids that we talked about, right? So it's again then a weak Arrhenius acid. Substance HCl. What is HCl? Hydrochloric acid. You can refer to the chart and see what is HCl, whether it is a strong acid or a weak acid. And these are all Arrhenius, because Arrhenius acid definition is that you have a hydrogen, ionizable hydrogen in your acid. So for HCl, you guys can figure out that it is a strong Arrhenius acid. Okay. And then the substance barium hydroxide is considered. Now this is a hydroxide, right? So how do you know whether you have strong bases or weak bases? So if you go to the next slide, relative strengths of bases. Strong bases, Arrhenius strong bases include water-soluble compounds. It could either contain oxides or hydroxide ions. The cations are usually those of the most active metals. Not all hydroxides also strong, but hydroxide has to be combined with one of these metal ions in order to be it a strong base. Metal oxide or metal hydroxide, where the metal has to come from your group 1 metals like lithium, sodium, potassium, rubidium, cesium. If your hydroxide or the oxide with any of these metals from your group 1, they are strong bases, and from the group 2, either it's an oxide or a hydroxide with calcium, strontium, barium. Now in group 2, when you go down, calcium, strontium, barium, magnesium, so you have a few more down the second group like barium, strontium, calcium. So the magnesium is on top, but magnesium is not here. You see, so only calcium, strontium, barium, when they are with the hydroxide, makes them a strong base, Arrhenius bases. And then the weak bases are ammonia and any of the ammonia derivatives, so amines. Okay, so they are weak bases. Now with that in mind, you can tell me barium hydroxide. So barium is a group 2 metal. Did we have barium as one of the metals that would make a strong hydroxide? Yes, right? Because remember calcium, strontium, barium. Right here. Calcium, strontium, barium, and their hydroxides are strong bases. So you can come up to the conclusion that it is a strong Arrhenius base. Okay. Okay, so the next one, calcium hydroxide, again, same argument. You can refer to the chart from the PowerPoints and figure out if calcium hydroxide is strong or weak. What is it? Is it an acid or a base? It has hydroxide. If it has a hydroxide, it's a base, right? And then which, if any of the following acids is strong? Phosphoric acid, water, acetic acid, carbonic acid. None of these choices are correct. Remember our strong acids. So your strong acids are going to be, you can remember that hydrochloric acid is a strong acid. HCl, HBr, HI, strong acid. H2SO4, sulfuric acid. And HNO3, nitric acid. And HClO4, perchloric acid. So these are strong acids. Do you see any of these here? Phosphoric acid, water, acidic, carbonic, none of these choices are correct. So you know the answer. Okay, you don't have any of these strong acids under number 6. And the number 7, which one of the following is a strong acid? You have acetic acid. What is this? H2SO4. H2SO4. Is it one of the strong acids? You can look it up. Phosphoric acid. H2SO3 is sulfurous acid. H2CO3 is carbonic acid. So you can refer to the strong acids list, which I have written here, and then you can answer the question accordingly. Ammonia. What is ammonia? I showed you from our list. Is it acid or a base? Ammonia is a base. So if you have forgotten, go to this slide. Weak bases include. You see here, this is ammonia. Ammonia is a base. Which one? It's a weak base. Okay. So there you have the answer. Substance ammonia is considered. Substance HClO4. What is HClO4 considered? Do you have HClO4 in our list here? Is it an acid, base, weak acid, neutral, a weak acid, a strong acid? Again, while looking up the list, you can figure that one out too. Easy. Which of the following is the strongest acid again? HF, HI, H2SO3, acetic acid, phosphoric acid. Again, you refer to the chart where I have written over here and see any of these acids you are seeing here belong to the strongest acids group. Again, you can answer that. That's easy. Which of the following is the strongest base? Sodium nitrate. What is sodium nitrate? Sodium nitrate is a salt, right? And boron hydroxide. And we have lithium hydroxide. And you have methylamine, aluminum hydroxide, lithium hydroxide, boron hydroxide, sodium nitrate. Which of the following is the strongest base? Now, sodium nitrate is a salt. It's not a base. Boron hydroxide is a base. Lithium hydroxide is also a base. So, this is a base. This is a base. This also a base. This also a base. And this is a salt. Boron hydroxide. And methylamine, this one is a weak base because it's an amine derivative. And then remember, there are 3 bases that has a metal ion, boron, lithium, aluminum. And then you refer to your chart here. Which ones are going to be the strong ones? Group 1 metals, lithium, sodium, potassium, rubidium, cesium. From the group 2, calcium, strontium, barium. So you look up these atoms and see which base has one of those atoms. And then you choose the strong one from there. I can see it. I hope you can see it too. Which of the following pairs has a stronger acid listed first? Which one has a strongest acid listed first? HBr, HI. Remember the order of the halo acids. We talk about in our lectures HF, fluorine, chlorine, bromine, iodine, HI. Now this is a weak acid and these 3 are strong acids. And as you go down the periodic table, what happened to the strength of the acid? Acid strength increases because the atoms are getting bigger and the bond length is getting longer, strength getting lower, so it makes the hydrogen to go away easily and making the bond weaker and making the acid more stronger. So from HBr and HI, which one is a strong acid? HI or HBr? HI is a stronger acid compared to HBr. So the first one is not correct. And then the next one, HNO2, HNO3. Nitrous and nitric. And here you can look up the number of oxygen compared to the number of hydrogen atoms. So the first one has 2 oxygens, the second one has 3 oxygens. The more number of oxygen atoms and oxo acid has, that's going to be the stronger one. So nitric is a strong acid. In fact, from your 6 strong acids, nitric acid is one of the strong acids. So that is not correct either. Now between HF and HCl, so here you have HF and HCl, which one is strong? Hydrofluoric acid is a weak acid, right? HCl is a strong acid, so that's not correct either. And HClO2 and HClO3, when you have oxo acid like that, you will have to look up the number of oxygen atoms. So the first one has 2, the second one 3. So again, the HClO3 chloric acid would be stronger than the first one written which was chlorous acid. Okay, so the E, H2SCO4, H2SCO3, this is selenic acid and selenous acid, I would say. So again, you can look up the number of oxygen atoms. The first one has 4, the second one has 3, similar to H2SO4. So the correct one is your E. Number of oxygen atoms exceeds the number of hydrogen atoms by 2 or more. But the second one, H2SO3, has 3 oxygen atoms compared to 2. Okay. Excuse me. Okay, the next one. Which of the following contains the strongest acid? Now, remember the pH. You can find out the stronger acid by looking at the pH. pH, what's the pH? pH equals negative log of hydronium ions, H3O plus. So, hydronium ion and pH has an inverse relationship. The more hydronium ion concentration you have, your pH would be lower. So, the more hydronium ion concentration is your strong acid. So, you have to look up which one has the lowest pH. 8.34, 11.88, 6.85. What is the pH for PO water? 7. So from this group, you find out which one has the lowest pH. That's going to be your stronger acid, which you can do, right? And then the next one, what is the pH of 0.2 molar hydrochloric acid? Now HCl. What is HCl? Is it a strong acid or a weak acid? It's a strong acid. So in water, it dissociates completely to give you, we don't even have to write the equilibrium arrow because it completely dissociates into ions, giving you hydronium ions and chloride ions. If you start with 0.2 mole HCl, this would be 0.2, this would be 0.2, 1 to 1 ratio. So we want to find out the pH. Remember the pH equals negative log of H3O plus concentration negative log of 0.2. So you take your calculator and then you turn it on. You find log 0.2 negative what? Okay, log 0.2. Yes, I have a number here. I got 0.698970004. So you should be getting a number like that and you round it off. And so you'll get a negative number. But at the front you have a negative. So that negative and the negative given by your calculator will make it a positive number. So I can see the answer here. So you do your calculation and figure out what is the value. Okay. Okay, the same thing. What is the pH of 0.002 mole HClO4? Same thing like that. HClO4 is a strong acid, completely dissociate into ions in the water. This will give you hydronium ions. Again, we don't have to write the equilibrium arrow. We can just put this arrow plus, ClO4 minus. So this is 0.002, 0.002. So pH is negative log 0.002. You find this answer. Okay. Let's see. Yes, I got a number. I got an answer, and I can see that answer in this in the answer choices. So you guys can do it and find out. Now you have potassium hydroxide solution, 0.0035. Again, you want to find out pH of a base, KOH. Will dissociate to give you potassium ions and hydroxide ions. Okay, so 0.0035, 0.0035, this would be 0.0035, right? So your pH would be negative log of hydronium ions, but what you have here is OH. So you, from this one, you can find out POH, not pH, POH. There would be negative log of 0.0035. You can find out your POH. Once you find out POH, how do you calculate the pH? Remember, pH plus POH both equals 14. Once you find out the POH, pH would be 14 minus POH. Okay, it should be a number greater than 7 because we are in a basic solution, right? So take your calculator and do the calculation. Log 0.0035 will give you a negative number. Something, I can see that number in my calculator, and you subtract that by 14, and that give you a number, and I can see that number here too. So you do your calculation. I showed you the path. Okay, wonderful. So that's how you would do for number 16. First find out the POH from the given 0.0035. You will get a positive number, and you subtract that number from 14. Okay, all right, I am going to erase this one so I can show you the next one. For number 17 is what we are working on. What is the POH of 0.025 molar HI solution? You want to find out POH, HI. This is an acid. Once you find out the acid pH, then you can convert it to POH. Okay. Again, this is an acid. HI in the water will give you H3O plus I minus. This is a strong acid, so 0.0250, and then the hydronium ion also 0.0250. So we can find out the pH from here. pH equals negative log of 0.0250. So you get this number. What you want is the POH. Once you find out the pH, POH would be 14 minus the pH value you're going to get from there. pH. 14 minus pH. That will give you the POH. Okay. All right. Easy. You can work on that. And number 18. What is the hydroxide ion concentration for a solution at 25 degrees Celsius that has hydronium ion concentration this much? Okay. Now I'm going to erase this one right here. Remember the relationship hydronium ion concentration times the hydroxide ion concentration equals Kw of water, which is 1 into 10 to the negative 14. We want to find out the hydroxide. Hydronium ion concentration given as this. So then the OH minus concentration would be 1 into 10 to the negative 14, and you divide it by 2.35 into 10 to the negative 3. That will give you the answer for this question. Okay. Okay. So number 19. What is the hydroxide ion concentration for a solution at 25 degrees Celsius that has a pH 4.29? Now we can approach this in two ways. One way is the pH is given 4.29, so we can find out the pOH. Okay, 14 minus 4.29 will give us the pOH, and from pOH you can find out the hydroxide ion concentration. Or else from the pH that is given to you, you can find out the hydronium ion concentration, and then using the Kw you can find out the hydroxide. Either way is fine. Let's do like this. Let's do the way that I said first. So pOH equals 14 minus pH. 14 minus 4.29. Okay, we can do it in our head too, but I'm going to go ahead and use my calculator, so I don't want to spend time. 9.71. 9.71 is the pOH. Basically, pOH equals negative log of hydroxide concentration, which is 9.71, right? 9.71. So then hydroxide ion concentration would be 10 base 9.71. I believe it's negative. Let's see. Shift log 9.71. I got a number and I have that answer right there. Yes, you put negative right there. Negative 10 base shift log or inverse log 10 base negative 9.71. Okay, that's how you would do that. And then we have only one left. 1 point, yeah, I'm not going to tell you the number. Okay, so that's how you find out the hydroxide ion concentration. And then the number 20. What is the hydronium ion concentration for a solution at 25 degrees Celsius that has pOH 5.640? So we were given pOH, we want to find out hydronium ion. So again, from here we can find out the pH, going to be 14 minus pOH 5.640 pOH. So 14 minus 5.64, 8.36. That's pH. 8.36, which is pH, equals negative log hydronium ion concentration. So then hydronium ion H3O plus would be 10 base negative 8.36. Let's see. Shift log 8.36. What? Okay, hold on. Shift log 8.36. Okay, I got a number. Yes, I got a number. That is one of the choices. That's correct. Okay, that's how you would do it. Alrighty. So pretty much that's how you're gonna do your homework problems. Easy. So practice these ones, do your own calculations. If I have done any mistakes, please feel free to let me know, so that way I can do the corrections. All right then, bye bye.